Hello and welcome to this video where we will use FastAPI and Scikit-learn to create an API that will serve machine learning model. I will make a very simple machine learning model using Random Forest Classifier to classify the iris dataset. As in all the machine learning courses, there are iris datasets, but not all of them will teach you how to create an API and then connect it to a front end, which is the idea with this video and maybe another video where I will put the front end in another video. Not sure yet. It depends on the length of this video. Maybe I'll put it in one video or I will separate it. We'll see. We will just create a very simple machine learning model. Then afterwards, we will create our simple fast API, and then we will test our API out, and then we'll connect to the front end. As simple as that. Let's move on to Kaggle to find the dataset. Here I am in Kaggle, and in Kaggle I just searched for the iris dataset and click on the datasets, and then you will find a lot of results. I'll choose the one with most downloads here, 200,000. Click on this one and then download this and create an account if you don't already have it. Let's move on to Visual Studio Code where I'll put in the iris dataset. Here I am in Visual Studio Code and you can see the iris dataset here, and here I also have assets which are basically pictures from Wikipedia, which I will be using for the front end later on. You can see this is the pictures for iris setosa, versicolor and virginica. You know that it's 3 different flowers, and the iris dataset, we can take a look into the preview. It looks like this. We have sepal length, sepal width, petal width, and then we have different species. That is it. Let's start with creating a virtual environment, uvven, and the source.ven bin activate, and uvpip install. IPy kernel to work with Jupyter Notebook. We need Scikit-learn. Then we need FastAPI. We need uvcorn to work with FastAPI uvcorn. And then we need pandas. That is it. Maybe seaborn as well. Yes. That should be enough. Yes. Then if we need something more, we'll install it on the way. Let's start with some explorations. Or creating the model actually. Model development, I will call it. .ipnb. Then I will also create a folder called models where I'll place in the finished models later on. Let's start with here. We'll create a random forest classifier. This is the model development stage. We start with, say that you are in different teams. You have the data scientists that work with developing the models. We'll make it very simple here. Then afterwards, you give it to, for example, machine learning engineer or data engineer that creates the API and then serves the model. That could be one way to work with this. Okay, let's choose pandas here. Import pandas as PD, and then we will have df equals pd.read CSV. We'll go into data/iris.csv and then df.head, and you can see the data here. Okay, first time takes a little bit longer time, but that's fine. We can do other things at the same time. Yes, now you can see it here. Sepal length, sepal width, petal length, and petal width, and you have species. Let's do df.describe here to see some statistics. .t to transpose it. You can see here sepal length, it goes from 4.3 to 7.9 and sepal width 2.0 to 4.4. These values we will use later on for restricting what our API can take in as value, that you don't want to have anyone putting in iris flower or lengths that are totally outside of normal iris species. Let's take a look into df species here. We'll see how it looks like. Okay, it's in letters or in language strings. We can take a look into value counts. We can see which classes there are. Yes, there are these 3 classes: setosa, versicolor, and virginica. Okay. Then we can move on to see. Let's see. I will have import seaborn as SNS to check out the SNS.pair plot, df, and then corner equals to true, and we'll have hue equals to species, just to look if is the data separable. We won't make a lot of data analysis here and feature engineering. Instead, we will just create our model soon, but I just want to take a look into this one. Okay, here you can see that petal length and sepal length are quite separable. Most of them is quite separable. This shouldn't be any problems to create a classifier. And then to create a classifier, we can create here Random Forest Classifier. Now it's time for from Scikit-learn.ensemble import Random Forest Classifier. Then we have model selection. So from Scikit-learn.model selection import train test split. And then x, y equals to df.drop. Let's see, drop species. So we'll have axis equals 1, df of species. Then we'll have, I'll just copy this from the lecture note. We'll make it a little bit difficult. We'll have a test size is 0.5. And then we'll have the classifier here equals to random forest classifier. And then we'll have classifier.fit, x train, y train. And then we'll do ypred equals classifier.predict. I'm going through this very quickly, but if you want more explanation on how these things works, check out my other machine learning videos. Now we have ypred. Ypred, you can see we can take a look into colon 10, for example, here. And then we'll take a look into ytest, colon 10. You can see that, let's see, dot values that you can compare them. Okay, now you can see, for example, here, iris versus color is the one we predicted. This is the actual value. That is the true value, iris virginica, etc. Note that the random forest, we don't need to scale the data. Okay, that is almost it. Now we will do some metrics. And from Scikit-learn evaluation, Scikit-learn dot metrics, import classification report, confusion matrix display, and then we'll print the classification report, ytest, ypred, and we'll do cm equals to confusion matrix of ytest, ypred, and then we'll have confusion matrix display of cm, and then dot plots. Okay, you can see there's some error here. Yes, and this looks really good. We're satisfied with this model. If you're satisfied with this model, what you do is that you train on all data. Basically is that we train with all data, and then what you do is that you want to export the model. These are a few steps. In order to do that, we'll do a classifier .fit x, y, and then we want to export this one. We want to import joblib. Joblib we use to dump the data. Joblib dump the model, basically. Classifier, I will go into models / iris classifier joblib, and I will do some compression equals to, this is a simple compression. There's different levels for that. Then I'll choose a protocol equals 5. Basically, this is for compressing the model, and then you can use it to load the model again. Basically, if you look into the models here, you will have this classifier joblib. Let's try it out. To try it out, we do like this. Classifier equals to joblib.load. We'll do models / iris classifier.joblib. We load this one, and then we need to create new test data, basically. For new test data, you can do like this. New test data equals to, let me just take out yx test, and we can take a few of them. We can, for example, take the first row here. We can take x test of 0. You can take a look into y tests of 0, and you can see it's iris setosa. What we want to do is that we want to, for example, we want to do a test on this sample here. Then we can do classifier.predict on, let's see, on this one. Let's see. Does not have valid feature name, was fitted with feature names. Okay. We probably need to do, let's see, I will call it the new test data. New test data equals to, or I'll call it sample test data. Sample test data equals to pd.dataframe of this one. Then I'll take a look into this one. Yes, it looks like this, but we should have it .t actually. Yes, that's better. Then we can put in sample test data. You can see it gives iris versicolor. Okay. The iris versicolor is actually correct because we take a look into whitetest.ilock0, then you have iris versicolor and you do classifier the predict sample test data and you get versicolor here. And you can see here that this is the sample test data and here is the X test. Okay, you have 0, you get this one, then you send it into the predict, which CLF is the one that we have loaded now from the models. Now we have our model finished. And it's time to create our backend, our API. API.py. To create our API, we start a new terminal. We make, let me see, from FastAPI import FastAPI. And then I will take API router as well. And I'll import pandas as PD. I will import joblib because we need that to load the model. Then we will need to have, we'll also create a constants here, constants.py. From constant, we'll have from pathlib import path, and then we will have assets path. We'll have different paths here. We'll have models path equals to path, then the file dot parent slash, let's see, models. Copy this one, and then we'll have data path, data, and we will copy this one. We will have asset path, assets path, and then we'll have assets here. Okay, then we can from constants import. We will have what path, data path, and we will want to have models path. This should be it. Also, we want to have from pydantic import base model and field. Now, let us create our app. App equals FastAPI. And then we will do read data. We need to create our df first. df equals to pd.read csv of data path slash, let's see, slash iris dot csv return df.toDict. That should be it as a starting point. UVcorn. Let's see, UVcorn API :app / reload. And then we'll go into this URL. I will divide this one, make it a little bit bigger here. And read data, let's see, we'll have to have at app.get. We can start with /API /iris /v1. Okay, now we have a lot of data and it looks really strange to have it in this way. What you need to do is take the orient equals to records, save this one, and now it looks much better. Now you have each record is in a dictionary, a JSON object. We have an array, JSON array of JSON objects. what we have now is that, okay, instead of doing this, I will just move this one into an API router. We will do router equals to API router prefix equals to this one. Then we will need to do router instead, router.get, and this is how we get that one. Then we need to do app.include router. It's important that this is after the endpoints. Now we will have our router here. Router equals to router. Save this one, reload this one. It works as expected. If we go into just like this, let me see, not found, because this is called router.get. We do API router, we do include router, save this one, slash docs. You can see here API iris v1. If I get this one, try it out, execute, and you can see, oh yeah, it is this request URL, basically. Basically, we don't write anything here, and we get this prefix by default. You need to go into /API/iris/v1 to get to this point, this endpoint. Good. Now we can create our prediction. That's quite easy. But for doing the prediction, we need to put in, we want to have some validation of the data as well. To get the validation, we have the fantastic library of Pydantic. Then we need to do, what I want to do is that here after app, we can do request, response, schemas. Basically, we get the data validation, class, iris, input. I want to have the base model here, VM, let's say VM, base model, colon, sepal length. And this one is a floating number of fields. Field greater than equals to. Here it's good that we go into the model development and we can see our values here. For example, here we can take greater than equals to 4, less than equals to a little bit more. Then I have picked the values here. I will say greater than equal to 4. Less than to equals 8.5. Then on and forth, I will just copy this one from my lectures and from my preparations. I've just looked into the model development and saw a little bit of values that looks, I've widened the range a little bit, but not very much. Okay, now we want to have a response schema as well. Class prediction output. As a base model, this one will have predicted flower. This one is a string, basically. What we want to do now is at router.get and then /predict. This is the endpoint. For this one, we want to have the response model equals to prediction output, that it checks that it's a string. Then finally, we do def predict flower, and we'll send in a payload. Is basically the data that is sent into this endpoint, iris input. The payload is of type iris input. So we use this to validate the JSON that comes in. What you want to do here is that you want to take model dump of the payload. When you do model dump of I'll show you what this means. I'll go into not model development, but say explorations, IPN B. Here I will show you, if we take this class that we created here, this class here. Okay, we need to have Pydantic. From Pydantic import DM, base model, and fields. Okay. To create this is our model, iris input. If you look into iris input, it's just a normal class. Then we can do iris input of sepal length equals to a value, say 4.2. Sepal width equals to 2.5, for example. Petal length equals to, say, 0, just to make it fail. Petal width equals to 1. Okay, if I run this one, you will see, perfect, there's a validation error. One validation error for iris input. Petal length input should be greater than 0.8. Pydantic is amazing thanks to this. It says that this one needs to be larger than, it needs to be greater than 0.8. We can have 0.9, for example, and you can see this is our iris model or iris input. If we call this payload, I can take payload here and run this one, and then I will do payload.model dump, and you can see that we get a dictionary back. That is very good. If we get the dictionary back, we can send this right into we can create a data frame based on this one. I'll show you how to do that. Import pandas as pd.dataframe, payload. This one won't give us, or this one will give us a dictionary data frame actually, but we can do it with model dump to get it into JSON. Then we will have index, we'll need to have 0 here. Perfect. Now you have a data frame. Yes, we could have solved it using just payload without model dump, but that is fine. We have this data frame, and this data frame we can send it into joblib as we did before. So in the API, we will perform this. We want to have data to predict equals to pd.dataframe, and here I will place in my payload.model dump, and then I will have index equals 0. When I have this, I can do classifier equals to joblib dot load models path / iris classifier dot joblib. Now I've loaded my classifier, and I can do prediction equals to classifier dot predict of my data to predict. Then return, I will make it into a predicted flower :prediction. Run this one, open this one, and try this one here. Try it out, execute. We will get back here predicted flower :string. Let me see why. Print prediction. Okay, and I will run this one, rerun this one, try this one out, predict endpoint. Get, we need to have post, of course. We're posting in data. Okay, post, try it out, send in this, yes, execute. We can see, there's an error here because, let's see, predicted flower. Let me see. Yes, prediction of 0 because we want to get the 0th value of it. Okay, try it out again. And we get 200. We get response body. Perfect. We get predicted flower and iris setosa. This is what we want. Okay, let's try this API a little bit. We have how to use this API. We have this request URL. You go in, you choose this request URL, and what you do is that you send in the data as you send in an object or a stream. And basically you can copy this one and go into your terminal, and you can see that it will work. In my terminal, I just paste this in, and you can see back comes predicted flower iris setosa. It works like this. We can try out different values here. For example, I have here 5. Let's see, execute this one. It doesn't work because of an error, because it cannot be. Let's see, it should say validation error, of course. It was a successful. Let me see. No, it's not success. Error. Yes, error. Here. Input should be less than 5. Okay. Input should be less than 5. 4.5. Then I can try this out. And you can see it predicted iris setosa. Okay, good. You can test this out and you will get different predictions. Now I'll show you how to get this data using Python. Here I need to install pip install HTTPX. Okay, then I will import HTTPX. What I want to do is making a request basically. To do that, I will have, let me close this one. We'll have URL equals to, I'll copy this URL here, copy, paste this one, and then I will have a payload. I'll just copy this one here. Payload equals to this. Let me see. Okay, I have this payload. And then I want to do with httpx.client. I'll have a timeout. It will time out after 10 seconds as client. And then response equals to client.post URL. And I will send in JSON equals to payload. And that is it actually. Response dot, raise for status. And then return response. Or not return response actually, because I'm not in a function. I'll just write out the response here. And you can see response 200. Okay, cool. What is the response then? Response.json. Predicted flower, iris setosa. Cool. Our endpoint works. And now we can place this into a front end. For example, we can place it into Streamlit. We can place it into SciPy front end. What we do is that we connect to this API, but I will leave that for the next video, as this video has become quite long. In this video, we have gone through how to create a random forest model for iris dataset. Then afterwards, when we have this classifier, we have trained on all the data, and then we have exported a joblib model. Then this joblib model, we use it in our FastAPI application. We created a FastAPI application to serve this. We created an endpoint that was for prediction. And then we tried out this predict both in the docs and in the curl using terminal, and also in Python we tried it out using HTTPX. You can see that it worked to classify based on the JSON that we sent in as payload. And then in the next video we'll connect it to a front end. For simplicity, we will choose Streamlit, but maybe in the future we'll pick also SciPy and maybe some JavaScript frontend such as React, etc. That will be quite interesting and when we have this API layer, we can serve whatever model we want and whatever data we want to whatever frontend we want. This is super cool and interesting. Thank you for watching this video, and I hope that you learned a lot. See you in the next one. Bye.